Welcome, friends. This is the series of videos for statistical analysis for business research method using SPSS. This is the first video where we are going to cover the correlation using SPSS. Let's see. In one of the city, it was found that whenever the ice cream sales is very high on that day, the crime rate, let's say murder rate, are also very high. And this city was in the northern hemisphere, let's say somewhere around Sweden, northern part of the Spain. Now, this two data, if you look at and do the correlation was very high. So you can take a pause on this and then think about the reason. Welcome back. So if you have speculated and then your mind goes that whether the ice cream affects the crime rate or the crime rate affects the ice cream, and we are trying to search a reason for that, right? If the correlation is positive and very high, it does not mean that there is a causation. So that's the first clarification which I want to bring here, that the correlation does not mean causation. Okay, let me explain how here. In this case, what happened? In summer, obviously the temperature is very high. The average temperature of the day is very high, and hence the people consume more ice cream. So there is a connection between the season, that's the summer, or the average temperature of the day, and the sales of the ice cream. So there's a causation that we can do. Now, since this part of the world, that's the northern hemisphere, somewhere in the northern part of the Spain or Netherlands, that part, in summer, the days are very long. Since the days are very long, the people are out of their home for more time. And since they are out of the home for more time, the criminal gets more time to conduct the crime. So now you can see here, the causation is that the season, that's the summer, having a longer day. In the winter, it's a smaller day. In the summer, it's a longer day, the criminal gets more time. In the summer, the temperature is high, that's why the ice cream sales is more. And then if we take the data of ice cream sales and crime rate, we find strong correlation. So what point I'm trying to make is that whenever you find a correlation between two values very high, maybe positive, negative, whatever, do not think that it will be always a causation between them. So we are going to say there is association. These two are associated. These two are correlated. That means they are associated. If you know logically there is a causation, you can put that. Now here you can see the arrow. What I'm putting up is a two-tip arrow. I'm not saying that one is affecting other or vice versa. Here I'm putting one tip arrow. That is because of the summer, ice cream sales is more. And similarly here, because of the summer, the days are longer. Since the days are longer, the criminal gets more time to conduct the crime. And that's why the murder rate is higher. That's the first clarification which I thought I'll just bring in before we go to the SPSS. Now in the SPSS, what kind of question we can answer using this? Let's say the data set what we are using is the employees data set, where we have a employee salary, employees performance data, their technical competencies, age, for how many years they are staying in the company, how far they are staying to come to the company. That means how much daily distance they are traveling, and whether the employee has appeared or has attended any technical training program or not, or any generic competency training programs or not. So such kind of data were collected. And from that data, we want to answer this question: does the performance has any relationship with salary? So let's see. So we are putting a null hypothesis. Performance score does not influence the salary, and performance score does influence the salary. So when we say the performance score does not influence salary, what we are saying here basically is that the correlation between performance and salary is not there. And you know, the correlation coefficient is given by Pearson correlation coefficient. That's we are going to denote as a R. So if the performance and salary does not have a correlation, that means the correlation is equal to 0. That's a null hypothesis here. Okay. And the alternate hypothesis says the correlation coefficient is not equal to 0. So friends, you have to consider that in all the cases, the null hypothesis always contains the equal to sign. And here the equal to sign is the correlation between performance and salary is equal to 0. So this hypothesis we are going to check. So what we will do first, we will try with the visual part. So please go to the SPSS. In the SPSS, go to the graph chart builder, and then once you do that, you will find this kind of chart. So please select the scatter plot, and in the scatter plot, select this first one, drag and drop this particular chart onto this window here. So drag it here. Okay. And once you bring it here, now bring the salary part, because we are trying to check the correlation between performance and salary, right? So bring the salary part here, and bring the performance part here, performance variable here. Once you do this, click OK, and you get a scatter plot. Now look at the scatter plot. So whenever you get a scatter plot, you try to draw, let's say, a rectangle around it. So I'm drawing a rectangle, just barring some points here. I'm just going to ignore those points. So if I draw a rectangle, something like this rectangle, like a brick, is, from left and bottom corner, it is going to be the right and top corner. It's sloping up. So you say there's a positive relation, positive correlation. But the width of the rectangle is very high. Why? Because the points are spread out too much. If the point are spread out too much, the correlation will be there, but it may not be as strong as anticipated. Okay. So if you have all the points on this line, very much near the line, we say strong positive correlation. If all the points are on this line, we say perfect positive correlation. Okay. If all the points are on, let's say, this line, let me select a different color. If all the points are on this blue color line, we say perfectly negative correlation. So we have perfect positive correlation, perfect negative correlation. If points are a little bit away from the line, we say strong positive correlation. And similarly, strong negative correlation. The points are too much away from the line, we say weak positive or weak negative correlation. The points are spread out around whole graph, we say there is no correlation. Okay, so we have a 7, let's say, variant. Actually, we are going to put an exact value, but just broadly speaking, we have a 7 this variance: perfect positive, strong positive, weak positive, perfect negative, strong negative, weak negative, and no correlation. So that's what we figured out from here. Now let's put some number to it. So once you double click on this chart, one more window will open. And the window will be similar, except we have a few more options here. So please click on this option, which will fit a line across these lines, across these data points. Okay. And that line, and also on the chart, we'll see something, this value will come up. That's called R square. It's a square of R, and R is a Pearson correlation coefficient, which is 0.146. So R is going to be square root of 0.146, which is going to be, let's say, plus minus 0.33 or something. We will take only positive value because this line is sloping upward, like this way. If the line was sloping like this, we would have taken negative value of that. Okay. So now we know the correlation value between performance and salary is around 0.33. That is square root of 0.146. Okay. So based on that, we can say, yes, there is a correlation. But is this correlation significant? We have to check at sigma level 0.05. There is a correlation, but is it significant? So for that, we'll conduct a proper analysis of correlation. And for that, you please go to the Analyze, Correlate, Bivariate. Once you click that, there's a window will open. In that, please select the variable salary and performance score. Ensure that the Pearson correlation coefficient is ticked here. Click OK. Once you click OK, you'll get a small table. And now here you can see that, let's try to understand, salary is here and performance score is here. So salary and performance score, these two are matching here. So this value we have to interpret. Okay. 312 observations are used, and the correlation between them is 0.383. And this correlation is significant. So this p value is less than 0.05. So at 95% level of confidence, we can say that this correlation is significant. If this value is not less than 0.05, we'll say the correlation is not significant. And in that case, we'll conclude that the correlation is equal to 0. So the null hypothesis was the correlation equal to 0. In this case, the p-value or significance value is less than 0.05. Hence, we are going to reject the null hypothesis and we are going to conclude that, yes, friend, the correlation between salary and performance is not there. Sorry, the correlation between salary and performance is not equal to 0. And there is a positive correlation, though it's not very strong. It's a weak positive correlation to the tune of 0.383, 0.383. And hence, we are going to say the performance score does influence the salary, or they are correlated, basically. Now, so once we understood the correlation between two variables, now let's see if we have a third variable and we want to check whether the third variable moderates the correlation between this. So in our case, the third variable is technical training. That means whether the employee has taken a technical training or not, does that status influence the correlation between these two, performance and salary? So for that, let's do the let's put a proper hypothesis. Technical training does not moderate the relationship or the correlation between performance score and salary. And technical training moderate the relationship between performance score and salary. So here the null hypothesis is going to be the correlation between performance and salary when the technical training is equal to 0 is equal to the correlation between performance and salary when the technical training is equal to 1. 0 means that those employee has not taken a training, and 1 means those employee has taken a training. Okay, so this hypothesis we are trying to test. So again, we plotted this scatter plot. Now so in the window where we say graph, chart builder, and scatter plot we selected, please select this tab, group and point ID. In that, ensure that this checkbox is ticked, grouping, stacking, variable. Once you tick this checkbox, something will come up here. That is, one field will come here. And in that field, please drag and drop technical training. So we are trying to plot a performance score and salary. And in that scatter plot, we want the data point to be colored or to be segregated in two groups. All those employees where the technical training was given and all those employees where the technical training was not given. Once you click OK, you will get a graph with two colored scatter plots, blue and in this case, blue and green. And we also have a legend for it. The blue color says the blue color data point corresponds to the employee who have not taken a technical training, which is given here. And the green color data points where the employee has taken a technical training. Now double click here. And again, you click this. So if you click this, you'll get a single line for all the data point together. And when you click this, you'll get two separate lines, one for the blue color and one for the green color. Once you click this, you get in most of the cases, you get a window. Ensure that linear is selected here. In some cases, by default, something else will be there. So you ensure that linear is selected here. Click on apply. Once you do this, you'll get a scatter plot where there are total 3 lines. One line for overall data, that's a black color line. The green line for the employees who have taken a technical training, and the blue line for the employees who have not taken a technical training. Now look at the slope of this line and also the R-square value of this line. The slope and R-square value are different, which means the status, whether the technical training was imparted or not imparted, does moderate or influences the correlation between performance and salary. Right? So visually we can conclude that, yes, there is some moderating effect is there. Now let's put it number wise. So for that, please go to the analyze correlate bivariate and get this window. In this window, we select this two and we get the correlation, right? But this correlation is for the overall, all data combined together. Now we have to bifurcate, we have to make it into two groups. So for that, please go to the data, select cases. Data, select cases, this window will open. In that, please tick this radio button. Once you do that, this window will open. And in this window, please bring technical training. In this window, please bring the technical training on here and put a condition equal to 0. That means, and then click on continue. Once you do that, what will happen? all the data points where the technical training is equal to 0, those will remain, and rest of the data points will be strike through. That means they will not be considered for the correlation analysis. In general, for all the analysis from this point onwards, unless we remove that condition. So once this is achieved, now go to the analyze, correlate bivariate, get the correlation window, and you will get the correlation output. Now, here, this correlation output is only for the employees who have not taken a technical training, right? Now, similarly, select. Now, again, you have to go to the data, select cases, change the condition, technical training equal to now 1, and do the correlation, and you get a correlation coefficient. So now we can compare this. Here, the correlation value is 0.330, which is significant, and there are 99 observations which are used to compute this. Here, the correlation value is 0.504, and 213 observations were used for this. And we can see both are significant. So this is a relatively weaker correlation, and this is relatively stronger correlation. So we can see that the status, whether the employee has taken a technical training or not, it does impact the correlation between salary and performance. In case of employees who have taken a technical training, the correlation is comparatively stronger. So that's a moderating effect. And hence, okay, so this is one more example. Does the competency training moderate the correlation between performance and salary? So now we have to put a condition to select the cases only for the employees who have taken a competency training. That means competency training equal to 0 and 1, taken and not taken. Okay. So competency training equal to 0 for the employees who are not taken a training, and competency training equal to 1 for the employees who have taken a training. So again, here we can see that both the correlation are significant. The value here is 0.326, here is 0.425. The difference is not bigger, that much bigger as it was in the technical training comparison. But still, we can see that there is some moderating effect onto the correlation between performance salary for the employees who have taken a competency training and who have not taken a competency training. Similarly, we can evaluate the effect of gender onto the relationship between stay and salary. So this is scatter plot. You know how to plot this. You can put those 3 lines, and you can see the slope and this is very much and the correlation value is also, see this 0.395 versus 0.288. Sorry, 0.288 versus 0.758. And it's visible that there is a moderating effect. And we can do the same thing with this data by making 2 groups. One group, male candidates, male employees. Second group, female candidates, female employees. So we have, it's an overall correlation, 0.628. Now, only for the male candidate, for that you have to go to data, select cases. The correlation value is 0.536. For female candidate, it's 0.870. We can say, yes, the gender does moderate the correlation between stay and salary. And it is stronger in case of a female as compared to male. That's a moderating effect. So this is the visual part, and this is the numerical part. So this here it's a bivariate analysis. At a time, only 2 variables can be taken together. And if you have multiple variables, that also can be done. So you have to go to analyze, correlate, bivariate. And in the correlation window, you have to put all the variables together. Still, it's a bivariate. Only thing, let's say all possible correlation between these 5 variables is given in one go. Okay. So for example, if you have to interpret the correlation between salary and stay, this is salary is here. The stay is here. So this column and this row. So basically this box we have to interpret. Okay. This box we have to interpret. And in this case, total 312 observations are used, 0.628 is the correlation, which is significant. So with that, we come to the end of the video for correlation. What we have covered, the misconception about the correlational causation. That's the first part we covered. Second, we visualize the correlation on a scatter plot. Then we evaluated effect of 3rd variable onto the correlation between the 2 variables. First through scatter plot, and then through values. Okay. And we took a couple of examples. Also, we learned how to find out the all possible correlation between more than 2 variables in one go. Thank you very much, friends.